Okay, welcome to our webinar all about Zookeeper and ClickHouse Keeper 2. My name is Robert Hodges, and together with the folks at Altinity Engineering, we've put together a pretty comprehensive treatment about how Zookeeper works with ClickHouse, and we will also talk about the new replacement, which is called ClickHouse Keeper. So before we dive in, I'd like to just give you a couple of items that will help you enjoy this presentation. One is the presentation is being recorded. Two ways actually. It's being recorded by Zoom, and I'm also recording it locally. We will send a recording out or a link to it, as well as slides at the end of this for anybody who's signed up. So you'll see this coming out to your email within a few hours after the webinar ends. So that's thing number one. Thing number two is if you have questions, and anybody who's used Zookeeper probably will, feel free to pose them. The best way to do it is to put them in the question and answer box, which is available from the Zoom little control panel that Zoom provides. Just throw them in there. I'll answer them. If they're relevant, I'll answer them right then and there in the talk. Otherwise, we'll get them at the end. And you can also throw things in the chat, but I'm not necessarily going to, I'm less likely to see it. Okay, so let's go ahead and dive in. And if somebody can, by the way, if somebody can just reconfirm that you've got good sound, that would help me. I just want to make sure that we're broadcasting correctly. Some introductions. So me, Robert Hodges, my day job is I'm Altinity CEO, but what's relevant here is I've been working on databases since 1983. It happens that has involved a lot of work with distributed systems. That's a lot of what we're going to be talking about today. It's the foundation that underlies projects like Zookeeper as well as ClickHouse Keeper. So this has been really fun to put together, and I'm looking forward to sharing both some of the things that have to do with basic distributed systems behavior, as well as a bunch of production experience that we have at Altinity that we've tried to assemble here and so that we can share with you. And speaking of Altinity Engineering, well, we have a company of, I think we've got about 42, 43 people on board. We're mostly engineers, at least 2/3. If you add up the experience we've had with databases, it's literally centuries. If you sum it up, we like to aggregate things, and that includes both databases, a huge amount of experience on ClickHouse, and then the applications that go around databases. And then Altinity, our company, we offer support and services for ClickHouse as well as the applications that people build on top of ClickHouse. We run Altinity.cloud, which is a managed platform for running ClickHouse and other things as well. And we're authors of the Altinity Kubernetes operator for ClickHouse. There are probably some of you on this call who have used it. So, and welcome to all of you. That's actually how I did the demos today. All right, so I'm going to dive into the content now, and the thing I would like to start with is to answer the question, why does ClickHouse need Zookeeper? It's this extra thing that we're going to be adding to what is a pretty clean product. One of the things I like about Zookeeper is that it's like MySQL or it's like Postgres. It's just one process. You start it up and you can start doing analytic processing, loading data, running queries. When we bring in Zookeeper, it's a new component. It's extra stuff to manage. You have to go get Java, so on and so forth. So why do we need this? And in order to answer this question, the best thing that we can do is go actually work through an example. So I want to start with the notion of horizontal scaling, because this is one of the fundamental ways that ClickHouse delivers huge performance and sort of outstanding performance in analytic queries. And what horizontal scaling means is that we spread out the data across many locations. Across the network. So we have replicated copies. So for example, this is showing 4 ClickHouse servers. It's split into 2 shards, the red shard and the blue shard. And then we have, within those shards, we have a couple of replicas. So a couple of copies of the data. And what this means is that we can take advantage of the processing capabilities of many machines. We can scale reads because we have multiple replicas we can look at. We also can scale writes because we aren't dependent on the I/O capacity of a single machine or set of machines. We have groups of machines that process subsets of the data. So this is one of the fundamental reasons, in addition to the many optimizations around storage and query performance, that ClickHouse is fast. So this is great. Let's go ahead and use it. So we had that table, events. Let's see if I got it named correctly. Yes, there we go, events local. I had a bunch of examples, so I want to make sure I got the right one. So we create a table called events local. If you haven't seen this before, the syntax it used to define a replicated table looks a little bit gnarly at first. We're not going to go too deeply into it, but just in case, what we're basically doing is creating a table with 3 columns. We are going to use an engine called replicated merge tree, and this is a table engine that understands how to replicate data. The way that it does that is it has this long string which tells it, gives it basically an identifier for this table, as well as the name of the replica, and then it has some standard ClickHouse things like partition by and order by. These are standard ways that tell ClickHouse how to organize the table in storage. We also use something called an on-cluster command, which is saying that when we run this command, we're actually going to blast it out, not just to the machine that we're running on, but across an entire cluster, which is a set of connected machines. And you see these little guys in squiggle brackets here, like cluster, like shard, like replica. These are actually, and database, these are called macros. And ClickHouse will automatically fill them in with proper values based on the machine that it's actually executing on. I'll show you how those macros are created very briefly a little bit later on. So this creates a table, and if this command is successful, it will go to all 4 of those nodes. We can then go ahead and pick any one of the tables and just connect to the host, one of the 4, and we can start inserting data. We could also use a distributed table, which is kind of like an umbrella table, and we could insert into that, and then ClickHouse will pick where to send the data for you. So this is all fine and good, and this is what you see as an application developer when you're building a sharded, replicated table, and then what it looks like to add data. So far, so good. So, excuse me. As with everything in computing, the first thing we have to ask is, well, what could go wrong? It turns out that when we have hosts communicating over a network, there's actually a lot of things that could go wrong. And I'm just going to give you 4 examples. We could send that on cluster command out, and we're sending it out to all 4 nodes, but what if it fails on one of them? Maybe we forgot to say if not exists, and the table already exists and it just bombs. Or the table's in the wrong form, or there's something wrong with that server that just causes it not to be able to, like it's missing a database definition or some other schema issue. It could just fail. So we have that, and we may need to repeat it. Other things is like a node could be offline for maintenance. So we're creating the table or we're adding data. One of the nodes is being maintained. Perhaps it's going through a version upgrade. It doesn't get the memo that something happened. And then there's other cases where replicas may make decisions to do things that conflict. And an example is a couple of replicas. People, as you're probably familiar, merge tree does background merges to consolidate data, and 2 replicas could choose to merge different combinations of parts to create a new part, in which case we'd have an inconsistency between the replicas. Or another one is that 2 replicas could delete different overlapping parts, and again, they could potentially conflict and even cause errors. So in general, the problem here that we have is that in distributed systems, things can fail, and when they fail, it means that you can create inconsistencies. We call this problem the distributed consensus problem. So having and what we need is some mechanism to have all of these nodes agree on what's the proper state of things, so that if one or more of the nodes doesn't get the memo, it has a way of finding out afterwards. And that's exactly what Zookeeper does. So when you set up a ClickHouse cluster and you connect to Zookeeper, two of the biggest things that Zookeeper cluster is doing for you is they are remembering these on cluster commands. They keep a list of them and show the order in which they should be executed. The other thing is they keep track of all the things that need to be replicated between tables, which are basically parts. So we call this, we'll dig into how Zookeeper works in a little bit, but basically you have a set of nodes and they store this as, you can think of it as a database, and the job of Zookeeper is to make sure that that database stays consistent and that no matter what happens, these ClickHouse instances or servers can just go ask Zookeeper, hey, what's the state of thing? What's the next on cluster command I should execute? What is the, if I'm a table, what are the parts that I've missed and I need to replicate from other replicas? That information is all stored in Zookeeper. So that's why we have that's why we have Zookeeper in this system, and why it's up till recently has always been a part of ClickHouse clusters. So at this point, it's worth digging into how Zookeeper actually works, because the mechanisms behind it are important, and you need to be able to understand a little bit of the plumbing to reason about what it's doing, particularly if it goes wrong. So let's dig in. So here's the basic architecture of Zookeeper. We will typically have, in a production system, we'll typically have 3 nodes. So stored on that run on separate machines, and these are the host names, Zookeeper 0 through 2, and they all talk to each other using something called the Zookeeper Atomic Broadcast Protocol. And we'll look at that in a little bit more detail in just a second. But the basic idea is these nodes work together and they form what's called an ensemble. That's what we call a collection of Zookeeper nodes that are storing information that can then be used by a ClickHouse cluster. So they they have different ports that they use to communicate among each other, but the servers, each of these servers then listens on port by default 2181, and all the Zookeeper clients, that is the people who want consistent, the services that need consistent information, they will dial in on port 2181, and they'll hit one of the Zookeeper clusters, and then they can either make changes, so do writes, or they can read data. And there are other operations, but it's basically, you can think of these being clients, and it doesn't really matter which of these Zookeepers they end up talking to. Regardless of which one they reach, they should get the same answer in each case. And that's because Zookeeper is maintaining consensus between these nodes. So how does it do it? Well, this Zookeeper Atomic Broadcast is one of a number of protocols that are used to maintain consistency in distributed systems. And the basic idea is the following. So if you have 3 nodes, one of these nodes will become what's known as the leader. And there's a process that the nodes use to make sure that they all agree on who the leader is. So we call that leader election. And then whenever a write arrives, so a write can be sent to any of the followers, for example, and we'll show you what Zookeeper looks like in just a second. It basically looks like a directory structure. You could add a node to that directory structure. So that's a write request. It could arrive at a follower like here, Zookeeper 2. And in that case, what will happen is Zookeeper 2 is the follower. It's not the boss. So what it does, it just sends that up to Zookeeper 0, that's the leader. And then Zookeeper 0 has a protocol where it will send this back to the followers as well as to itself and ensure that they see it and commit it. And the idea here is that really what makes this whole thing hang together is that excuse me, you have a single leader who ensures that the messages get to everybody in exactly the same order, and that the followers that receive them also acknowledge that they have them. So so this is the heart of this protocol, and there's a number of protocols like RAF, Paxos, Zab. They all work around this basic idea that there's somebody who's the boss, and that person takes care of serializing the messages. This has some consequences. So since the leader coordinates the writes, your performance is going to be gated on a couple of things. One is when you write something, it's like how capable is this Zookeeper Zero host? If it's like a little teeny 2 vCPU uh, VM running on Amazon, it could be pretty slow. And as a result, the write rate that you can have here is going to be quite slow. The second thing that's going to gate it is how quickly can it distribute these writes out to its followers, or at least a majority of them. And so again, if the more in so here for the basic gate is how big is the machine and how fast does it execute, how fast is its storage. But then the other thing is how many of these followers do you have to get acknowledgments from. The more you have, the slower it goes. So that's a really important performance consideration that is going to be true for that's something you need to keep in mind when you're running Zookeeper or any similar system. Read requests, on the other hand, are not gated by the leader, because since every machine in the or every node in the ensemble is supposed to have a consistent copy of the data, the read can arrive at any of the servers, and it'll just look up what the data is and then hand it back. So there are many more details to this. I'm not going to go into it because there's a bunch of, for example, if you're familiar with this, you'll know that there's a huge number of corner cases around things going wrong, and they tend to be mostly around what happens if the leader no longer has what's called a quorum, which means that in this case you have to have the leader plus at least one follower for the leader to guarantee that things will be consistent. It can lose quorum, in which case Zookeeper will then stop and it'll go through a process to elect another leader. There's other cases, and there's other kinds of there's a bunch of corner cases around this. You can go in and read about it, but basically Zookeeper takes care of it for you, and for the most part it works. Okay, so this is basically how Zookeeper works. So what does the data look like? Well, I mentioned that it looks like a directory structure, and we sometimes call this a directory service, a distributed directory service. And the basic idea is if you go into Zookeeper, you would see something that looks an awful lot like a file system, except that they are these special things. They're not really files, they're called Z nodes. And you can think of, there's a root node, and then you'll see, if you have ClickHouse attached, you'll typically see the root node, and then you'll have ClickHouse, and then you'll have a couple of different chains coming off that. The first chain that we show, the one called first, that's for a cluster called first, and then it tracks all the tables, and this is the part where we're keeping track of parts. There's also another chain called the task queue, and that's keeping track of on-cluster events. There's also other things that we use Zookeeper for, like alerting, but I didn't include them here. These are really the principal ones that you'll see, as you're operating the cluster and have to configure it. So one interesting thing about this is, unlike a file, a Z node is simultaneously a directory as well as a file. So it can have content. You can think of it as being a bit like XML. So XML can actually have some value inside the tags. And for example, when we walk down the task queue and look at the queries, we'll see something like this query 000 whatever. And if you look at it carefully with the right tools, you'll see that it actually has a value here, which is drop table if exists, which was a command that I ran when I was first setting it up. So this is the structure that you have. One really important thing about this is structure is very, very complex, and as you get to tables, there's actually in addition to just the lists of parts, for example, that we need to replicate, there are many other things. And it's not, you can look at this stuff, but it's not really safe to modify it because it's so complex, and it's the only software that should be modifying things in here, unless it's a dire emergency, is ClickHouse. Okay, so that's the directory structure. So what kind of information is stored in the Z nodes? I've already talked about this, but the two major kinds are tasks, and including pending and completed on cluster commands, and then table information. just a bunch of things. Just to pick one of the cool features that replication has had for many years is what's called deduplication. So it's a list of hashes for input for inserted blocks. And what that allows us to do is if we have an insert that fails on one replica, we can turn around and send it to another. And when that replica receives it, it will go look at the list of the inserted blocks of their hashes. And if it turns out that block somehow already got in, it will just ignore it. So that's an example of something where we want to be consistent across many tables working in a cluster. And if you want to find, actually, one interesting thing, the C++ code on this is incredibly readable. If you go look in I believe it's in, if you're familiar with ClickHouse source code, you can go look at the storage class for replicated storage, and it has all the info. It describes all of this information and gives you a lot of guidance about what ClickHouse is actually doing. This is one of the great things about open source. So we talked about why we need Zookeeper. We talked about how to, how Zookeeper works inside. And what I'd like to do in the next part of this talk is I'm going to go ahead and jump in, and we're going to talk a little bit more about practical things like installing and configuring. So installing Zookeeper is pretty easy on in most cases. So here's an example on installing it in Ubuntu. You do an apt update, you do an apt install, and you want to install Zookeeper plus this thing called netcat, which you'll see is a command that we use. It's also abbreviated as NC. It's a command we use to send commands to Zookeeper itself. And those are the only two commands, as long as you have it in your repo. One thing to check is we recommend installing Zookeeper 3.4.9 or greater. There are some limitations on this. You can check in our knowledge base. I think 3.6 we do not recommend at this time, but just check it out. As long as you get the stuff that comes out of this was Ubuntu, I believe 1804. The stuff that comes out of the repo is fine. And then once you've done the installation, you're going to go ahead and have to do some configuration. So, and before we get to that though, it's really important to talk about a few things that are really important to keep Zookeeper happy and to ensure that you have high performance and consistent data. And that's to put it on really good hosts. So for example, it's really important not to share Zookeeper with other applications. So Zookeeper, if it runs on the same host as ClickHouse, what will happen is if ClickHouse is a pig, right? It's designed to be a pig. It's designed to use every resource it can get hold of. So if ClickHouse gets really busy, it could steal resources from Zookeeper. In which case, when you do an operation that requires a response from Zookeeper, it could be delayed, or Zookeeper could even fail. It could, like have problems connecting with, establishing quorum or broadcasting message. So putting Zookeepers on dedicated hosts is really important. Another really important thing is put the log on an SSD and make it dedicated. So Zookeeper has, we'll see in a second, has a notion of a transaction log. And then from time to time, it takes a snapshot of the data. But this transaction log is where Zookeeper instances remember all the things that they've committed, all the messages and the writes, if you will, that they've committed. Putting that on a separate SSD is really smart. You want to have low network latency between Zookeeper nodes. So not necessarily, Zookeeper doesn't pass a huge amount of information, but it needs to have pretty quick response. 4 gigs of RAM. You definitely want to disable swap. If you have a Zookeeper instance and it starts to swap, in other words, it starts to have to read memory from storage, you're dead, particularly in a production Zookeeper, because it will become very slow. And then finally, it's written in Java, so you're going to need to tune the Java heap. And so, for example, like if you have 4 gigs of RAM, we recommend setting it to 3. And the Java heap is just like the heap memory that's used by the Java process, and that's where it stores an in-memory copy of the database. So that gets us to looking at specifically what's going on with this process. And so Zookeeper is, as I said, written in Java. So here's one happily running. And when it runs, it basically maintains an in-RAM copy of the Z nodes. So if it has to answer a question, it's not going to have to go to storage. It's just going to get it out of memory. And then there's 4 different kinds of files that it refers to. The first is we need a server instance ID, and this is just it's stored in a file called myID, and it's going to be an ID that's like you start with 1, 2, 3, so on and so forth. You set that. And then so that's one of the things you have to do when you're installing is you have to fill that out. And each of the servers needs to have a different number. Since you don't change the number very often, this is pretty easy to do. The second thing you have to do is you have to go look at the config file. That sets your parameters. The default Zookeeper out of the box that comes from, for example, apt install needs a couple changes. We'll look at those in a second. And then you have what are called the data directory. That's where your snapshots are stored. These are from time to time. Zookeeper will take a full copy of the data and it'll store it in the snapshot. And then the data log dir, that is where the transaction logs are stored. If you don't set this, it will put it in the data dir, which is okay for development, but generally speaking, you want to set this to a separate path going to a fast SSD. So these are your moving parts, and you can when you're setting up Zookeeper, there's some things that you are going to have to set in this zoo.config file. So let's just have a quick look at them. You have things like this is a really important setting. It's called auto purge. What this does is Zookeeper collects these snapshots, but it by default does not remove them. At least in older versions of ClickHouse, you must add, or excuse me, older versions of Zookeeper, you must add these lines. So what this is saying is every hour we're going to look around to see if there's stuff we can get rid of, snapshots, and we're going to keep a snapshot count of 5. That means we'll have at most 5 snapshots, and this keeps them from just accumulating indefinitely and filling up your disk. When that happens, Zookeeper stops, and it's really bad. So you don't want that to happen. Second thing you have to do is you have to give a list of all your all the servers that are in your ensemble. So here they are with their names. The location of your data directory. This is defaults to varlib Zookeeper and on Ubuntu, and then your data log dir. And I've set it to SSD because I've got some like an SSD plugged into this. So this is your basic configuration. There are other things that you can set, but these are the most important ones. Starting it is pretty straightforward. So this shows you just sudo -u Zookeeper, and you're going to run the zkserver.sh command. And you can set this up as a service in a initd and things like that. It's pretty straightforward to do. And then here's some things that are called 4-letter commands. We'll talk a little bit about them, but these are just simple ways of commands that you can send to the Zookeeper to make sure that it's happy and okay. The most common one is "Are you okay?" That's just like a ping. If you run ping on ClickHouse, it has a similar function. It just says, "Hey, I'm alive," and if it says "I'm okay," it means that not only is it alive, but it actually has it actually has a leader and things are functioning correctly. Monitor, well, we'll see these in a minute, but these are other things you can run. So pretty easy command line stuff to control this stuff. Now, once you set Zookeeper up, you need to tell Zookeeper where, or once you set Zookeeper up, you need to tell ClickHouse where it is. So we do that with the Zookeeper settings, and so normally what you'll do is put this in a file in config.etc ClickHouse server config.d, and it'll just say something like, hey, here's my Zookeepers. This is actually in Kubernetes, so this DNS name here is actually a load balancer, and it'll go find and it tells it it's port 2181, and here's our distributed DDL path. So and this, once you've done this, then ClickHouse, when it comes up, will read this file and it'll know the Zookeeper it needs to talk to, or the ensemble, I should say. Another thing you need to do is you need to add macros if you're going to use on cluster commands. If you remember, a few slides back, I issued this on cluster command, and um, I had, I was able to put in these macros, these little things in squiggle brackets. The values come from a file that's by convention named macros.xml, and we typically put that in, again, etc ClickHouse server config.d. So that's setting up Zookeeper and getting it to start. Let's talk about administration. And there is so much stuff that we could say about this. I can't possibly cover it all, but I'll try and give you the highlights. First question we get is, how many Zookeepers are enough? This is a great question. And it turns out the answer is, if you haven't dealt with distributed systems, it turns out this answer is surprising. So basically you have three possibilities. If you're developing, one is fine. And in fact, with ClickHouse Keeper, there's a really great variation on this that I'll show you. But one is great because you don't really, if it goes down, hey, no big deal, restart it. You're not putting any valuable data in there anyway. If you're running in production, it turns out 3 nodes is the best overall. You can use 5, but what will happen, as we showed, is that the writes can be slower because the leader will need to contact more followers to be sure that everybody got messages. So you'll notice here, though, that they're always odd numbers, and that's because in order for a Zookeeper Ensemble to function, it needs to have quorum, and so quorum is defined as a majority of the of the servers, and so in the case of development, a quorum is 1. In the case of production, we're going to set where we're running 3, the quorum is 2. Why? But you have it, and then so you have these kind of interesting effects. It's like if you actually have 2, that's going to be less available than a single replica. This is not kind of counterintuitive, but the reason is simple. If you have 2 servers, you can't make the quorum be 1. Because what can happen is, if the servers can't see each other and the quorum is 1, they will both continue operating and serving writes separately, and then you'll have what's called a split brain. And so as a result, you must make the quorum 2. Well, you have 2 servers and you don't have any surplus, so it's more likely, if you have 2 servers and they have a certain chance of failure, it's more likely that one of them will fail because they basically multiply. And so as a result, you get a lower availability than you do with 1. Same thing applies with 4. So to make a long story short, 3 is the best number, and that's the one that we almost always recommend. What's in Zookeeper? So one of the really cool things that ClickHouse, if you're a ClickHouse fan the way we are, ClickHouse has great system tables, and one of the most useful ones, and in fact the table that you want to look at here, is system.zookeeper. And what that does is ClickHouse will go out and it will basically run queries on the directory tree in Zookeeper. This allows you to do a couple things. One is it allows you to see what's in the tree. You use this where path equals, and you give the path. ClickHouse won't guess it for you. But the other thing it does is, if this query works, it means ClickHouse can see Zookeeper and Zookeeper is working. So it's a really important tool. Whenever you suspect something is wrong, first thing you do is dive in and run this query. And if it succeeds, okay, at least you can see Zookeeper. You can look for something else. But if this doesn't succeed, like if it bombs out, it'll time out, for example, then you know that there's something wrong with Zookeeper. Another thing that you can do is, if you use this correctly, it will actually print the znode values. So this is just another example, just showing how we can get the excuse me, see the commands that are in the DDL queue. Another way that you can talk to Zookeeper, if you need to know what's in there, is you can use zkCLI. That's the basic tool that comes with Zookeeper. So it's pretty primitive, really very painful to use, but it also allows you to navigate this tree and look at things. There are many other tools that allow you to look at the Zookeeper hierarchy. Just pick one, and there's like visual tools, for example. I don't usually use them. I usually do command line, but they will give you a good view of what's going on. Zookeeper, as we already introduced, has these things called 4-letter word commands. So are you okay, conf, cons, monitor, server. These are just quick commands that you can send to the Zookeeper, and it will blap out some text information that helps you understand whether Zookeeper is up. In the case of monitoring, it dumps a bunch of stuff that you can then feed into something like Prometheus, and understand what the health of your server is. There's a number of other commands. These are just some of the more common ones. And as you see, here's the standard thing. You just say echo, give the name of the command, and use NC to blast it up to port 2181. Speaking of monitoring, there are a number of approaches, and it's sort of hard to give you like a, hey, this is the one size fits all. Some people are using things like Nagios, older things. There's a routine called check zookeeper.pl. In the slides, this is actually linked to the project. The newer approach that we tend to see is people will use Prometheus and Alert Manager and Grafana, and there's actually a Grafana dashboard that's available from Grafana Labs that you can use. There's a lot more to say about this, excuse me, and but you can check out the knowledge base, the Altinity knowledge base, and we have a page on Zookeeper Monitoring which gives a bunch of ideas about how to do this. You should not go into production without having monitoring set up on this. It is not hard to do. Zookeeper makes it pretty easy with the commands, and there's software that does it, but you just need to set it up. Now, monitoring will help you deal with problems, and excuse me, I'm going to talk about 3 or 4 here that come up pretty commonly. The first is read-only tables. So you'll be happily inserting data, and all of a sudden you'll start to see failures like this. The table is in read-only mode, so you can no longer update that table. And what that means, if you have a replicated table, is that ClickHouse cannot contact Zookeeper to post the information about the insert, and so it basically makes the table read-only until it's fixed. And the idea here is this is designed to prevent inserts from, for example, arriving on multiple servers or just all kinds of chaos. It will basically stop the process until you can get Zookeeper fixed and restore consensus. So here's how to deal with it. And this is a problem that, if you run for any length of time, you're going to see this problem. So the first thing you want to do is here's ClickHouse, and we're just keeping this simple: one ClickHouse and one Zookeeper. ClickHouse maintains a single-threaded TCP/IP thread that's talking to Zookeeper that is a standing thread. So you can just go ahead and select from system.zookeeper, and if you get results from that, that means at least we can see Zookeeper and it's responding. So something else must be going on here. We can then go over, if we don't see Zookeeper, we can go over to the Zookeeper host, run an RUOK command, just see if it's even live and responsive. If this comes back, then we can go. If this comes back and Zookeeper is up, but things are not responsive, then we have to go look and see what's happening. In fact, even when that doesn't come back, you need to go look at the logs. And there's just a bunch of things that could happen. You could have disk space full. That would be bad. But you could have lost quorum. You could have had what's called a ZXID rollover. Zookeeper keeps IDs on every message, and because of the way that the IDs are organized, they basically use a 32-bit int, or a pair of 32-bit ints. From time to time, that second 32-bit int, which just increments with every message, will roll over, in which case Zookeeper will force Zookeeper to do a leader election. And so in that particular case, Zookeeper will become briefly unavailable and then will come back. So you want to go look and see if you're getting ZXID rollovers. This can happen if you're sending too many writes to ClickHouse. And then there's other things. You just go look at the log. Most of the time it's pretty obvious what's happening. You just have to know where the log is to go find it. Session expired. So this is another thing that comes up fairly commonly, which is that ClickHouse for some reason loses its connection to Zookeeper. And so again, same thing as when things go read-only. There's a couple things you do. First of all, just ignore it. If it doesn't happen very often, this is common in distributed systems, that there is a single connection, And if it were interrupted for any reason, like there were a change in network routing or like something got busy, just retry. Most of the time it just goes away. But if you see it happening a lot, then it's a sign that something is not right with Zookeeper. So look for errors. Particularly look for ZXID overflow. That's one that I've hit before. And a common cause of ZXID overflow, too many writes, is that you try to do something where you have multiple applications using the same Zookeeper. In that case, or you have like a huge number of tiny inserts. These are two things that can cause Zookeeper to overflow. You could have too many parts in the table. This can happen when there's just too much load because you have a huge number of parts. And then there's a setting called Jute max buffer. Oops, misspelled. This is a specific setting that can be too small, and I believe it has to do with the size of buffers we move across. If that setting is too low, you can also have connections fail. So these are just things that you can go look at, and that will get you past that error. And then there's big failures. So more than just something being temporarily offline or losing a connection, you could lose a Zookeeper node. That's actually really easy to fix. You have a VM, it burns up, or disappears. What you do is just create a fresh node with that same Zookeeper instance ID, and generally speaking, you would try and repeat the host name, and then you just start it. So go ahead and install Zookeeper, replace the same my ID, and make sure that the zoo.config files are all consistent, so this like if you change the name for any reason, that everybody knows it, and then you just start the new node. And what will happen is it'll join the cluster, and then it'll get all this stuff replicated over and keep going. The more serious problem is if you lose Zookeeper, the entire ensemble, and this is a very sad event. It happens from time to time, and it is bad. So because basically you've just lost all the data. It used to be this was pretty much a catastrophe. In that case, yeah, I think an immediate vacation would be, and let somebody else deal with it would probably be your first thought. But once you get over that, you can bring up a new Zookeeper Ensemble, just make sure it's working. And there's a new command that was actually put in by one of the folks at Altinity last year called System Restore Replica. And if you go to this link, the System Restore Replica will show you how to well, basically what it'll do is it'll restore the metadata by reading it from the Zookeeper server and then posting it over into posting the let me reverse that. It'll read the metadata as ClickHouse comes up, and it will post it back to Zookeeper, so it will backfill the information that Zookeeper is missing. I haven't personally run it, but it's apparently a real lifesaver compared to what you had to do before, which was ugly. You had to like convert tables back to merge tree and then make them replicated, and it was really, really painful. So this is a big improvement. And that's it for Zookeeper. I want to talk about one of the most interesting developments in ClickHouse over the last couple of years, and that's ClickHouse Keeper. And Alexander Sapin is on here. I welcome Alexander. Alexander is the author of this, and if you want to join as an attendee, I can promote you. But he put this together. It's a really, really interesting piece of code. So we're going to talk about that briefly, just to give you the background. What is it? Well, it's a from scratch re-implementation of Zookeeper. So there were a number of choices about how to, and we'll give some reasons why Zookeeper, why many people wanted to replace it. But basically, what it does is it more or less completely mimics the Zookeeper API as well as those little admin commands. One difference is it uses Raft, which is another distributed protocol, kind of similar to Paxos, but allegedly easier to understand. And the implementation, I believe, is New Raft, which was developed at eBay. So the effect is the same. When you're using it, you can't really tell the difference for the most part. It is written in C++, which ensures that it's performant and doesn't require as much parameterization as Java does. and most important, it's part of ClickHouse. So you no longer have to go and find this extra thing. And so as a result, there's no installation to talk about here. It's um, it's just install ClickHouse, and ClickHouse Keeper is part of it. So why why did the ClickHouse team do this replacement? Well, that's a good question. A big reason, and I think you'll see proof of this in just a couple of slides, is it's really important that ClickHouse has this sort of philosophy that everything you need to run is just there. So for example, Kafka integration is built in, and having to have extra stuff that you have to go find and manage, it just makes it a lot more difficult. So that's a really big motivation. Second thing about Zookeeper is it's no longer cool, and it was developed as part of I believe it came out of a lot of the Hadoop work, if I recall correctly. It's no longer actively developed as more modern projects, which means that when there are security problems, they don't get fixed quickly necessarily, that new features don't appear very quickly, so on and so forth. Java is a complexity for many people. It adds extra dependencies. If you want to run lean, it requires tuning. A lot of people just find Zookeeper hard to operate, and then there are some specific problems that contribute to this, like this ZXID rollover problem that has been a long time issue, as well as things like logs being uncompressed and stuff like that. So these are all good reasons for replacing Zookeeper with something better. So one of the ways you can use it is just as a drop-in Zookeeper replacement. So you can, instead of running Zookeepers, you run ClickHouse Keepers, and you can have three of them. I show them talking to each other. We'll show how they're configured, but basically it does exactly what Zookeeper does. And when you set it up like this, it's actually kind of hard to tell you're not talking to Zookeeper. So I'll show you how you can tell in a minute. But so you'll basically install these, and in this case, what you would do is run them on a separate host, or a separate set of hosts, and the same kinds of, there are some general, we're learning more about like what are the best practices, but in general this is something where you want to keep it off to itself. It also has logs. You want to keep those logs on high performance disk, so on and so forth. You don't want to share it with other applications. Most of the things that apply to Zookeeper are going to apply here. The other thing though, and this is where this gets super interesting, is ClickHouse Keeper can run just inside ClickHouse itself. So here's an example on the right where we actually have a single shard, and it's got three replicated tables. And instead of having an external, having an external Zookeeper ensemble, we just run the ensemble in the ClickHouse nodes themselves. This is a really interesting development. Because it basically means that you don't have three extra processes, and you have a much simpler architecture. One thing I should point out is that you'll have to think about this. There are many ways you can use this, but you'll have to think about this, because what this would mean is if each shard had its own set of ClickHouse keepers, they wouldn't talk to each other. And so on cluster commands, unless I'm really missing something, won't run across all shards, which is something that they do with when you're using a traditional ensemble that's separately logged. However, the thing I really want to point to is the most interesting one, is if you're a developer and you want to start developing and building things with using a schema for replicated and sharded tables, you can just activate ClickHouse Keeper inside your one ClickHouse instance that's running on your laptop. This is a really, really great feature, because it used to be that when you're developing on a laptop or using a single instance, you would typically use merge tree tables, and then as you got closer to production, you might switch them over to replicated merge tree. You don't have to do that anymore. You can start with the replicated. You can get the schema right from the beginning and have all the Zookeeper stuff, using the same code paths as you will in production. I think this is a huge step forward, and a really like a reason that if you're looking at ClickHouse right now, this is a very strong reason for wanting to adopt this now. So ClickHouse Keeper has configuration just like Zookeeper. It's typically stored in this Keeper server under this Keeper server tag, and you have things like there's your server ID, your port, some coordination settings like what's the log level for this is a very simple one, and then the raft configure. You can see this is stuff for the raft, the consensus protocol. In this case, we just have one server, and here it is. This was actually set up not on a laptop but on a machine running in my closet. So that's it. And so as long as you're as things are sane, anybody can set this up and actually have this running locally. It's really handy. If you have a larger ensemble, then they would have more complex files. So for example, the raft configuration would include all of the servers. And there are many other settings. You can check the documentation up on clickhouse.com. It describes all the other things you can change. And here's what it looks like. So you have ClickHouse, you have ClickHouse Keeper running inside it. You have that Keeper config file that we just showed you, and then you have logs and snapshots. And as I want to emphasize again, put the logs on fast disk. Because that'll improve your throughput. So the cool thing about this is, there were many ways this could have been done, but the cool thing is that because it replaces Zookeeper, it just works. So on cluster commands and replication, they work the same way as they ever did. You can use system.zookeeper to show the directory structure. The 4-letter commands work. You can use zk cli.sh or any other tools. They should all just work. I use zk cli.sh. You can't really tell the difference once you're inside. So this is really a really good reason for why this was done the way it was done. And in fact, it's a little hard to tell the difference. So you can run this 4-letter command server, and there's several of these commands. They will print out what version they're at. And of course, you can see here that this is ClickHouse 22.3, and along with a few other stats. But this is really one of the few ways that you can really tell the difference from within ClickHouse that you're talking to ClickHouse Keeper. Important question that didn't have an answer until recently is how to migrate. So you're running, if you're starting out new, ClickHouse makes a lot of sense to go to ClickHouse Keeper. We'll talk about our assessment of it in just a minute, but you can just set it up and there's no migration because you're doing a new installation. But if you have Zookeeper and you want to migrate, there's a program called ClickHouse Keeper Converter, and that will convert your logs to the new format, and then you can just get going with ClickHouse Keeper. And it does include an outage, so you're going to have to stop Zookeeper. There's an option here. This is just from, I'm really copying, this is the documentation for this is pretty straightforward. This is more or less straightforward, straight what the documentation tells you. And the only difference is you want to test the daylights out of this before you apply it, because if you do move forward and you have a problem because you hit something unexpected, that would be an issue, because you can't really just revert Zookeeper back. You're now going to have inconsistent state. So test this very carefully. This is fairly new. And so this comes to the final question in this presentation: is ClickHouse Keeper ready for prime time? And Alexander, I think would say yes. Our assessment is it's getting there, and we mean this in the best possible way. I think that for me, I mostly have a developer outlook on this more than sort of a production DBA. It is incredibly convenient for development. I think this is a huge step forward. It also fixes a bunch of known problems like ZKID overflow. Our experience, we're starting to run it in large clusters, and so far so good. There won't be there's still going to be a few things that get put out, but the ClickHouse core team has done a really excellent job of testing this. They did a bunch of Jepsen tests on it, for example. It's been used in an increasing number of production servers, and including stuff that we're running. And our assessment is it's ready for production use on 22.3, which is the next ClickHouse LTS. And I want to say, congratulations to Sasha Sapin for doing such a great job. It's a really, really great step forward. And we're looking forward to using it. And in future, we'll have a lot more information about, just, hey, here's the ins and outs of running this thing in production yourself. That's it for the content of this talk. Here's a list of references, a bunch of things that you can refer to. ClickHouse docs, they have, for example, for ClickHouse Keeper, the Zookeeper docs. I think the single best source on Zookeeper is probably Altinity knowledge base. We've run Zookeeper for years, and there's just a bunch of tips about production things. For example, like figuring out snapshot intervals and things like that are really, really important to cover. There's also a wonderful talk from Alexander Sapin that he gave at the SF Bay Area ClickHouse meetup, and that's where he shared ClickHouse Keeper and the background behind this, how it works internally, explains the Raft protocol. Check that out. There's also a recording of the talk. There may be other versions of this now, but this is a great talk, and I highly recommend it. And that is it. I'd be happy to take questions. And Sasha, I don't know if you want to add anything to this, but if you do, I can go ahead and I'm going to unmute you if you want to make any comments. It's great to have you on, and congratulations again. Okay, I can see, Alexander, I can see you're unmuted, but I don't see I can't hear you. Are there any other questions? I'd be happy to answer them if I can. Some of them may go deeper than I know, but in which case we'll get back to you. Feel free to post them in the question and answer or in the chat. It's Alexander. Yeah, Alexander, thank you so much. And by the way, yeah, your talk was wonderful. It was the first place I went and looked when I was doing this. And thank you so much. And it's stuff like this that makes ClickHouse really, really a pleasure to work on. Is just being able to, to have these talks and be able to share this information. Okay, well, we're getting to the top of the hour. I don't see too many. Here's a question. Yeah, so simple question. You did mention you think it'll be ready for production and you're still experimenting with it. As far as you've explored it, is there any reason to prefer Zookeeper over ClickHouse Keeper? Yeah, a big reason is if you have it working already. If you have Zookeeper working already, there's not a huge motivation to move. And I'll give you an example. We run over 100 clusters in Altinity.cloud. It's all based on Zookeeper. We have a few problems with it. Occasionally people will beat it up, but they're more things that wouldn't necessarily be solved by ClickHouse Keeper. They are, just somebody is overloading it because they're misusing ClickHouse itself. So Zookeeper, I did mention these problems. It sounds kind of scary, but Zookeeper, once it's up and running, provided you have it hosted on capable machines or VMs, as the case may be, has very few problems, and there's years and years of experience on it. We know how to debug problems. So if you know how it uses, if you know how it works, I wouldn't be in a hurry to change. On the other hand, if you're bringing up something new, I would definitely be looking very hard at ClickHouse Keeper, and if only because the development path is so much easier, being able to have that. To have it embedded is just wonderful, and over time it will definitely be the preferred solution. So if you're looking to the future, that's a good reason to move. Are there any wonderful question. Thank you so much for this. Are there any plans for the ClickHouse operator to support running Keeper embedded on ClickHouse? That is the question. Yeah, we have been asked that question many times. The answer is yes. Yes, we will support it. And let me tell you, if I have to do it myself, we will support it, because I was setting up ClickHouse Keeper. I do all my setups in Kubernetes. It is painful to set up if you just do it, do a raw setup. just using a basic deployment, or if you're a Kubernetes person, there's some tricks to making sure that it comes up and establishes consensus. So big yes on that one. I don't have a date, but it should be soon. Now that ClickHouse Keeper is looking really really stable and usable, we'll get working on it. We ourselves will eventually convert to it in Altinity.cloud, and I would imagine the other cloud providers will use it as well. Okay. Great. I think that's it for questions. Everybody, thank you so much for attending today. It's been a real pleasure putting together this talk. If you have any further questions, just drop by altinity.com. You can, there's a contact us. We also have a Slack channel. You can send email to me. I should have put it down here, but if you send email to info@altinity.com, you'll be able to contact us, and we'd be happy to answer questions about this. And obviously, Sasha Sapin is available on GitHub, so go ahead and feel free to post questions. It's a really great piece of tech. The ClickHouse Keeper is a great piece of technology, and um, we're happy to share information about it. Good. With that, I wish you all a great day, and thank you for attending.
Recording stopped.